diameter of a circle are parallel, we need to prove that AB and CD, the two tangents, the tangent lines at the end points of diameter, the two tangents, these are end points of diameter of circle. This is the diameter, it's passing through center of the circle. We need to prove that these two are parallel to each other. AB is parallel to CD. To prove AB is parallel to CD, let us take the name, the point of contact from center to the tangent, it's X and Y. We know that OX is perpendicular to CD. From the theorem, the line drawn from center to the tangent of a circle is perpendicular. So OX is perpendicular to DC. OX is perpendicular to DC. And also OY is perpendicular to AB. So we can say that if OX is perpendicular to CD, OX is perpendicular to CD, then it makes an angle 90 degrees on each side with a tangent. So let us take one of the side, one of angle here, that is angle OXD is equals 90 degrees. OXD is 90 degrees. Similarly here, OI is perpendicular to AB. Then, the both the sides it makes 90 degrees because it's perpendicular to each other. Then, it's 90 degrees. So, the angle of OYB is 90 degrees. Let's take this 1 and 2. OXD is 90 degrees and OYB is 90 degrees. So from 1 and 2, we can observe that angle OXD and angle OYD are alternate angles. Alternate angles are nothing but two angles. Alternate angles are nothing but two lines are intersected by some other line. It's called transversal. Then interior angles and either side of transversal are called alternate angles. These two are either side of transversal. Angle 1 and angle 2 are either side of transversal. These angles are called as alternate angles. So when the two lines L is parallel to M, then we can say that alternate angles are equal, that angle 1 is equal to angle 2. It's a property from transversal. So the same way when we apply this here, these are angle OXD and OYD from 1 and 2. These are alternate angles. So we can say that if alternate angles are equal, the lines will be parallel. So that's the reason 1 is equal to 2. Angle OXD is equals to angle OYB. Alternate angles. Here, alternate angles are equal. That's the reason. The circle touches the sides of quadrilateral ABCD and PQRS respectively. Show that the angles subtended at the center by opposite sides are supplementary. Let us recall. The circle touches the sides of quadrilateral ABCD at PQRS respectively, and show that the angles subtended at the center by pair of opposite sides are supplementary. Let us see here. Circle touches the sides of quadrilateral ABCD. Circle touches the sides of quadrilateral ABCD. Touches the sides of quadrilateral ABCD. Let's take the names ABCD. A circle touching the sides of quadrilateral ABCD. Circle touches the sides of quadrilateral ABCD here at PQRS. Circle touching at the sides of the point Q, P, Q, R, S respectively. Here we have understood circle touching the quadrilateral at the point P, Q, R, S respectively. We have drawn. Then we need to show that angle subtended at the center. Let's take the center as O. Angle subtended at the center. The angles will be subtended with the vertices. What are the angles are subtending here? That angles are angles subtended pair of opposite sides. Pair of opposite sides. These two angles with these sides. The side of the CD is making an angle with this here at O, that is nothing but COD, and opposite side the angle is making with this is angle AOB and these two angles are supplementary. We need to prove that. So to prove angle COD plus angle AOB is 180 degrees, and also we have other two sides that are nothing but EC and AD. Here angles made with this side is EC and other one is AD, and also these angles are supplementary that are angle BOC and angle AOD. It is supplementary, is nothing but 180 degrees, and here it is given that ABCD is a quadrilateral and PQRS are touching the sides of ABCD, the circle, and we have inside the circle that circle is touching the sides of quadrilateral PQRS, and then here we need to prove these two opposite angles, sum of opposite angles are supplementary, and here let's take that the property of circle and tangent. A tangent drawn from external point of a circle are equal. That is, the tangent drawn from external point of a circle are equal. We have taken as AB and P is an external point. Then PP is equals to PE. Then we call that is a tangents drawn from external point of a circle are equal. Using this theorem, we can see here using this theorem, we can see that A is an external point to the circle and then is an external point, then tangents are AS and AP. So these two tangents are equal. Then we can understand that from other theorem, when the two tangents are equal, so we know that angles made with these two tangents are equal. That's nothing but angle AOD and angle AOB are equal. Let us take these names are 1 and 2. These two angles are equal. The reason is the two tangents are equal, and that angles made with two tangents are equal. And using the theorem, tangents drawn from external point of a circle are equal. Two tangents drawn from external point of a circle, and then angles made in the center so here angles with the center, well, angles are formed. These two angles are equal. The reason is we have proved that when the triangles are formed here, two triangles are congruent, then these two angles, 1 and 2, are equal. So here, using the same theorem, angle 1 is equal to angle 2. And then angle 2 is equal to angle 3.